So what do the boiling point of water, a severed earthworm, and the French army under Napoleon all have in common?
Well, I mean, if you asked a standard 19th century physicist or, a biologist or a military historian, they would probably just look at you blankly.
Right, they'd see three completely unrelated things.
Exactly. Three isolated phenomena, totally separated into different academic departments.
But if you ask Karl Marx or Friedrich Engels, they would tell you something pretty radical.
Yeah, they would.
They'd argue that these three incredibly disparate things are actually driven by the exact same hidden law of the universe.
And that hidden law is exactly what we are digging into today.
Welcome to the deep dive, everyone.
Today, we're pulling from a massive stack of sources. Specifically, we're looking at selections from the Marx and Engels collected works.
Which, in academic circles, people usually just call the MECW.
Right, the MECW.
Yeah.
And it is this sprawling collection of, well, philosophy, economics, and natural science.
I have to admit, when I first looked at the syllabus for today's deep dive, I was legitimately intimidated.
Oh, I don't blame you at all.
I mean, we are talking about concepts like dialectics and dialectical materialism.
Yeah, those phrases alone sound incredibly dense.
They do. They sound like the kind of academic jargon that's almost designed to keep people out of the conversation.
Like a barrier to entry.
Exactly.
Right.
But the deeper I got into your notes, the more I realized this isn't just like dusty philosophy.
Not at all.
It is essentially an operating system for reality.
Ooh, I like that.
Yeah, it's like a mental model for understanding how things change.
That is the perfect way to frame it, actually. Think of it as a diagnostic tool.
Okay, a diagnostic tool.
Right. Because Marx and Engels didn't invent change, obviously.
Right. I think change was already happening.
Exactly. But they popularized this highly specific mechanical framework for analyzing why things change.
Rather than just observing that they do.
Precisely. They argued that if you understand the internal friction of a system,
And that could be any system, right?
any system, whether that system is a chemical compound or a planetary nebula or, a human society.
Right.
If you understand the internal friction, you can understand its trajectory.
Okay, before we go any further into the weeds here, I do want to throw out a quick boundary for our listeners.
Good idea.
Because the names Marx and Engels obviously carry a massive amount of historical and, well, political baggage.
To put it mildly.
Yeah. Their writings form the bedrock for communism. They critique capitalism ruthlessly, and they make very specific predictions about the collapse of class structures.
Right, the political destination of their ideas.
But our goal today is entirely divorced from endorsing or critiquing those political destinations.
Absolutely.
We are acting strictly as guides to the source material provided.
Just reading the text.
Exactly. We are looking under the hood to see how their analytical engine actually worked.
It's a methodology.
Right. We're studying the machinery, not necessarily the political road trip they took the machine on.
That's a vital distinction for us to make. We are focusing on their methodology today.
Because they applied it to everything.
They did. They applied this specific lens to a staggering variety of fields, and the underlying logic is honestly fascinating regardless of your own economic leanings.
So we need to define this engine.
We do.
And to do that, the text suggests we actually have to start with its opposite.
Right, because Engels spends a lot of time criticizing what he calls the metaphysical mode of thought.
Okay, stop right there. Because when I hear the word metaphysical today, my mind immediately goes to, like, the New Age section of a bookstore.
Crystals, astrology, ghost hunters.
Yes, exactly. But Engels is using it in a completely different way here, isn't he?
He is, yeah. In the context of 19th century philosophy, the metaphysical mind is one that categorizes the world into rigid, isolated boxes.
Isolated boxes.
Right. To a metaphysician, as Engels defines it, things and their mental reflections are totally isolated.
So they don't interact.
Well, they are considered one after the other and apart from each other. They are fixed, rigid, given once and for all.
It sounds to me like treating the universe like a giant Excel spreadsheet.
Oh, that's a great analogy.
Like, every object has its own cell, its own row, its own column, and they just don't bleed into each other. A is A, B is B.
That spreadsheet analogy captures it perfectly, because in the metaphysical view, a thing either exists or it doesn't.
Right.
A thing is either positive or negative. A plant is a plant, an animal is an animal.
That's very clean.
It is a very comforting, orderly way to view the world, which is why Engels notes it's so prevalent in common sense and basic science. You classify things to study them.
But the sources argue that this spreadsheet model completely falls apart when you actually look closely at reality.
It does.
Because reality doesn't stay in its assigned cell.
It bleeds everywhere. And that is exactly where dialectics enters the picture.
Okay, so define dialectics for me.
If metaphysics is the spreadsheet, dialectics is the science of universal interconnectedness.
Universal interconnectedness.
Right. It is the science of motion, of development, and fundamentally of contradiction.
So it's messy.
Very messy. The dialectical mind comprehends things not in their isolation, but in their essential connection. It looks at their origin and their ending.
So instead of looking at, say, a frozen photograph of a river and saying, this is what the river is.
Right, that would be the metaphysical view.
Right. Dialectics demands you look at the entire water cycle.
Exactly.
You have to understand the melting snow on the mountain, the erosion of the riverbank, the evaporation into the clouds.
Because the river isn't a static object.
It's a temporary manifestation of a massive, moving process.
And crucially, the texts point out that every organic being is, at every single moment, the same and yet not the same.
What does that mean exactly?
Think about your own body. You are constantly taking in new matter through food and oxygen, right?
Sure.
And you are constantly expelling old matter. Cells are dying, new ones are forming.
Wait, so I am literally not the identical biological entity I was at the start of this recording.
You are literally not.
That's wild. The spreadsheet view says I am a fixed identity.
But the dialectical view says you are a biological process that is slowly turning over its own inventory.
Turning over its inventory. I love that.
Which brings us to the origins of this whole framework.
Because Marx and Engels didn't invent this, right?
No, the texts highlight that they did not invent this dynamic way of thinking out of thin air.
Who did they get it from?
They adapted it from the German philosopher Georg Wilhelm Friedrich Hegel.
Hegel?
Yes. Engels credits Hegel with being the first to develop dialectics in an all-embracing form.
But there is a massive caveat in the text about Hegel.
A huge one, yeah.
Because it says Hegel developed it in a mystic form.
Yes, mystic.
Which raises the question, if Hegel built this brilliant engine for understanding process and change, why did Marx and Engels spend so much energy trying to, as they put it, rescue it?
Right.
What was broken about Hegel's original design?
The fatal flaw, according to our sources, was Hegel's idealism.
Idealism.
And again, we really have to translate that term for modern listeners.
Right, because when I think of an idealist, I think of someone who is, hopeful or optimistic.
Exactly. But in philosophy, idealism means something totally different. It means you believe the fundamental substance of reality is mental or spiritual, not physical.
Okay, walk me through how that applies to Hegel's engine.
Hegel believed that the physical world, so the trees, the planets, human civilization, was essentially just a reflection or like a physical shadow of an eternal abstract concept he called the absolute idea.
The absolute idea.
Yes. For Hegel, this absolute idea existed somewhere out there from eternity, long before nature or human beings even existed.
It's hard to wrap your head around.
It is. He thought the physical universe was just this idea alienating itself into matter.
So matter is just an afterthought.
Basically. And human history was just the long dialectical process of the idea slowly waking up and coming back to self-consciousness through us.
That feels incredibly abstract.
It is deeply abstract.
It sounds almost like the concept behind the movie The Matrix. But instead of a computer simulation, we are all just like avatars in the dream of a giant cosmic mind.
Wow, yeah.
Like the ideas are the actual reality, and the physical universe is just a byproduct.
That is a very apt translation of Hegel's cosmology, actually. He applied the dialectical process, the tension, the contradiction, the evolution, primarily to this mystical realm of thoughts.
And Marx and Engels didn't buy that.
Not at all. They looked at this massive philosophical architecture and argued that Hegel had the entire universe backwards.
Right. The texts say they thought he was upside down.
Engels famously wrote that Hegel's dialectic was standing on its head.
So if it's upside down, how did they flip it?
They executed what they called the materialist flip.
The materialist flip.
Yes, they argued that the physical material world is the primary reality. The ideas in our heads do not create the physical world.
So the opposite of the Matrix.
Exactly. Rather, our ideas are merely reflections or mental images of the real material world in motion.
So the material world comes first, and our thoughts just mirror it.
You've got it. They threw out the mystical absolute idea, what they termed the mystical shell, and they kept the rational kernel.
And the rational kernel was the engine itself?
Yes, the mechanics of the dialectical method itself.
So they took this brilliant, complex engine for analyzing change totally out of the clouds and just bolted it directly onto physical matter.
They grounded it completely. The fundamental premise they established is that motion is the mode of existence of matter.
Motion is the mode of existence of matter.
Meaning, you cannot have matter without motion, and you cannot have motion without matter.
Okay, but what about something that's just sitting there, like a boulder in a field?
Even a seemingly static object, like a boulder sitting in a field, is hurtling through space on a planet.
Sure.
Its atoms are in constant thermal vibration,
Right.
and it is actively undergoing chemical weathering from the atmosphere.
So it's not static at all.
No. The boulder is an event. It's a slow-moving process, not a permanent fixture.
That is a radical shift in perspective. To view a rock as an event.
It really is.
But it also presents a major problem, I think.
How so?
Well, if matter is always in motion, always morphing and shifting, why isn't the universe just random, chaotic, static?
Ah, I see what you mean.
Right. Like, why do we have structured things like stars or biological ecosystems or human societies? There have to be rules governing all this chaos.
And that leads us to the absolute core of the MECW texts we were examining today.
The laws.
Yes. Engels outlined 3 fundamental laws of dialectics. These are the rules that supposedly govern all of nature, history, and human thought.
Let's get into them.
The first is the law of the transformation of quantity into quality.
The transformation of quantity into quality. We really need to make this concrete for people. What is the actual mechanism here?
Well, the central idea is that change in the universe does not happen in a perfectly smooth, endless, uniform slope.
So it's not just a straight diagonal line pointing up.
Right. Instead, you have gradual quantitative changes. So adding a little bit more matter or a little bit more energy or taking some away.
Just incremental steps.
And for a long time, the fundamental nature or the quality of the object remains stable.
It stays the same thing.
But eventually, that gradual addition hits a critical threshold.
Like a breaking point.
Exactly. Hegel called these nodal points. Once you hit a nodal point, a sudden fundamental leap occurs. The accumulation of quantity forces a radical change in the quality of the thing itself.
The sources rely pretty heavily on the exact sciences to prove this, which I really appreciate because it pulls all this philosophy down to earth.
It makes it much easier to grasp.
Let's look at the physics example they give regarding the temperature of water.
Perfect example.
You have a pot of liquid water. You apply a heat source. So you are adding a quantity of thermal energy.
Yes.
The temperature rises from 50 degrees Celsius to 60 to 70.
So the quantitative change is constantly accumulating.
But the quality of the water holds steady.
It's still water.
It gets hotter,
Yeah.
but it is fundamentally liquid water. It behaves like a liquid. But then you hit 100 degrees Celsius.
The nodal point.
Yes, you reach that nodal point. You add just a fraction more heat, and a sudden phase transition occurs. The water violently boils, it breaks its liquid state and transforms into a gas.
It becomes steam.
The quantitative pressure basically forced a qualitative leap.
And you see the exact inverse if you subtract the quantity of heat.
Oh, right.
You cool the water down, degree by degree, until you hit 0 degrees Celsius. Suddenly, the liquid locks into a solid, crystalline structure.
It becomes ice.
Exactly. Every metal has a specific melting point. A specific minimum electrical current is required to make a specific wire glow. Physics is built entirely on these qualitative leaps.
The chemistry example in the text is even more dramatic, I think, because it shows how adding a tiny amount of the exact same material creates something monstrously different.
Oh, the oxygen example.
Yes. Take atmospheric oxygen, O2. 2 oxygen atoms bound together. You breathe it, it keeps you alive, it's odorless and colorless.
Essential for life.
Right. Now, apply a quantitative change. Add just one single atom of oxygen to that molecule, turning O2 into O3.
Which is ozone.
And ozone is not just, extra oxygen.
No, it's not.
It is a completely distinct chemical body. It has a pungent, chlorine-like odor. It is highly reactive and toxic to breathe in high concentrations.
Just from adding one atom.
Exactly. By simply adding a quantity of one atom, you haven't just made the molecule bigger. You have fundamentally transformed its chemical identity and how it interacts with the universe.
The texts are absolutely saturated with these chemical examples.
They really are.
Look at carbon and hydrogen compounds. You take a specific combination, like methane, add a carbon atom and 2 hydrogen atoms, and you get ethane.
And you can just keep going, right?
Yeah, keep adding that exact same numerical proportion, and you move through propane, butane, pentane.
They're all different.
Entirely different. Each quantitative addition produces a substance with completely different boiling points, freezing points, and physical properties.
Okay, so it works for boiling water and chemical bonds, which is neat. But Engels scales this up to human beings, and this is where I think the framework gets real teeth.
It becomes very practical.
There is an anecdote in the text from Napoleon Bonaparte concerning his military campaign in Egypt, specifically focusing on his French cavalry fighting the Mameluke cavalry.
It is a brilliant illustration of how this law applies to human organization.
Break it down for us.
So Napoleon observed that the Mamelukes were arguably the greatest individual horsemen and swordsmen of their time.
So on an individual level, they were elite.
Incredibly elite, but they lacked modern military discipline.
Okay.
Now, the French cavalry were relatively poor individual riders compared to them, but they were highly disciplined and organized.
So if you put them in a one-on-one duel, the French soldier's going to lose.
Almost certainly. Napoleon explicitly wrote that 2 Mamelukes were undoubtedly more than a match for 3 Frenchmen.
Wow. Even outnumbered, they'd win.
Because the individual skill, the quality of the single soldier, was superior on the Mameluke side. He even noted that 100 Mamelukes were generally equal to 100 Frenchmen.
So at that scale, the individual skill still balances out the organization.
Exactly. But the math completely breaks down when you scale it up.
It reverses, right?
Totally reverses. Napoleon stated that 1,000 Frenchmen would invariably defeat 1,500 Mamelukes.
I want to translate this into a modern analogy because I think it perfectly captures what Marx and Engels are arguing here.
Go for it.
Imagine a massive multiplayer video game, something like League of Legends or Call of Duty.
Okay, I'm with you.
You take 5 players who are mechanically brilliant, they have incredible reflexes, they win every single one-on-one fight, but they refuse to talk to each other and just run around doing their own thing.
Like playing solo.
Right. Then you put them up against an actual professional esports team.
Right.
The pro players might individually have slightly slower reflexes, but they communicate, they share resources, they execute coordinated strategies.
The pro team wins.
The pro team will absolutely slaughter the 5 isolated superstars every single time.
That maps perfectly onto Marx's analysis of the Napoleon anecdote.
It's the same dynamic.
It is. Marx argues that the coordination of the many creates what he calls a new power.
A new power.
The strict discipline and organization of the 1,000 French soldiers fuse them into a cohesive, singular military organism.
So the quantity changes the fundamental nature of the group.
Yes. When you reach that quantitative nodal point of scale, the quality of the fighting force changes. It is no longer just a collection of guys on horses. It's a machine.
And the machine wins.
And the new quality of that machine completely overwhelms the scattered individual skills of the much larger Mameluke force.
The takeaway here is just incredibly sticky. More isn't just more. Eventually, more becomes different.
That is the absolute essence of the first law. But, as you brought up earlier, this creates a logical friction.
The source of the movement, right?
Right. We've seen how piling on quantity forces water to boil or an army to win, but that feels like a one-way street of accumulation.
Yeah, things don't just passively accept more and more energy forever.
Exactly. Where is the pressure coming from? Water doesn't just passively accept heat. When steam hits a cold window, it violently condenses back into a liquid.
Right. There's a constant push and pull.
So what is creating that internal friction inside systems that drives them toward these qualitative leaps in the first place?
And that friction is the domain of the second law, right? The law of the interpenetration of polar opposites.
Yes. This is where dialectics completely breaks away from the spreadsheet model.
Okay, explain this one.
This law states that all systems in nature are driven by internal contradictions.
Internal contradictions.
It argues that polar opposites, positive and negative, attraction and repulsion, north and south, cannot exist without each other. They interpenetrate. They mutually define one another.
So they aren't errors in the system.
Not at all. The tension between them isn't an error. The tension is the engine of reality.
Okay, I'm going to play the role of the stubborn metaphysician here for a second because this is where my brain naturally pushes back.
Please do.
It sounds highly poetic, tension is the engine, but surely some things are just purely one thing.
Give me an example.
If I hold a Dar magnet in my hand, the North Pole is painted red on one end, and the South Pole is painted blue on the other.
Standard magnet, sure.
They are opposite, yes, but they are physically separated by 3 inches of metal. They are isolated.
Well, the sources anticipate that exact objection, actually, and they use the magnet to dismantle it.
Oh, they do.
Yeah. Engels points out the flaw in trying to isolate those poles. If you take that bar magnet and you snap it exactly in half, trying to walk away with a purely north piece of metal and a purely south piece of metal, what actually happens?
Oh, wow. You don't get two isolated poles, do you?
No, you don't. You instantly get two brand new complete magnets.
Right.
The previously neutral center where you snap the metal instantly polarizes. The severed end of the north piece becomes a south pole, and the severed end of the south piece becomes a north pole.
So you literally cannot isolate one from the other.
Their existence is mutually dependent. A north pole only has meaning and physical reality in its active tension with a south pole.
So the contradiction is built into the material itself.
Exactly. You cannot slice a contradiction in half to get rid of it. It just replicates.
The tension is baked into the material. And, there is a biological example in the text that gave me pause.
The worm.
Yes, it is gross. But it proves the point so vividly that biology operates on these same embedded polarities. It concerns a specific type of segmented worm.
Yeah, the texts point out that organic life is full of these structural polarities. You have a head end and a tail end, a mouth, and an excretory system.
And the text notes that if you cut this specific worm in half, similar to the magnet, it doesn't just die.
No, it adapts.
The biological polarity violently reasserts itself. The cut end of the front half of the worm, which used to be the middle of the animal, dynamically grows a new negative pole.
Right.
It forms a new anus. But the really wild part is the back half of the worm.
This is the crazy part.
The cut end of the back half, which was previously pointing towards the old negative pole, transforms into a positive pole. It becomes a new mouth.
It is a striking illustration. The positive and negative poles aren't just labels we stick on the animal to categorize them.
Right. It's not a spreadsheet.
They are active, opposing forces inherent in the living tissue itself. The biological system requires that contradiction to function, and it will aggressively rebuild the opposing pole if it is disrupted.
So we have magnets, we have segmented worms, but Engels scales this law all the way up to astrophysics, doesn't he?
He goes massive with it.
He points to the Kant-Laplace theory.
Right. Immanuel Kant and Pierre-Simon Laplace proposed a hypothesis for the formation of the solar system, which was the cutting-edge science of Engels' day, and honestly remains conceptually foundational.
What did they propose?
They proposed that the sun and planets formed from a massive, rotating, incredibly hot nebula of gas.
Okay, so where do the polar opposites come into play in a giant cloud of space gas?
The entire evolution of that solar system is viewed as an epic cosmic struggle between two opposing forces: attraction and repulsion.
Attraction and repulsion.
Gravity is the force of central attraction, constantly pulling the gaseous particles together, trying to crush the mass into a single point.
And what's pushing back?
Heat. Heat acts as the force of repulsion. The thermal energy radiates outward, causing the particles to violently push away from each other.
So the creation of a planet isn't just like a peaceful gathering of rocks in space.
Not at all.
It is a massive billion-year tug of war.
Exactly, the dynamic Engels is highlighting. The condensation of that gas cloud into a central sun and orbiting planets only occurs because the heat, the repulsive force, is gradually radiated away into the cold of space.
So one side slowly wins.
As the repulsion weakens, the attractive force of gravity slowly gains the upper hand, forcing the matter into denser and denser spheres. But the critical takeaway for dialectics is that motion itself is the continuous interplay of attraction and repulsion.
This brings up a massive structural problem, though, to my mind.
What's that?
We have this cosmic tug of war.
Yeah.
Gravity pulls, heat pushes. If they are perfectly balanced, nothing happens. It's just static.
True.
But if one side wins completely, like if gravity crushes everything into a black hole, or if heat blows the nebula apart into isolated atoms, the system just ends.
It's over.
Right. So it sounds like this dialectic engine is just a recipe for a universe that either freezes completely solid or blows itself to pieces in these violent qualitative leaps. How do we actually get evolution out of this? How do we get complexity?
That structural problem is exactly what is solved by the third law,
Okay.
which is arguably the most complex and philosophically dense of the three laws, the law of the negation of the negation.
The negation of the negation. The terminology is just brutal.
It is dense, I will give you that,
Yeah.
but it's the actual mechanism of progression.
How so?
It explains why the contradictions and qualitative leaps don't just result in barren destruction, it provides a directional arrow to time and to development.
That means change builds on itself.
Precisely. The concept argues that a thing is negated, meaning it is destroyed or fundamentally overcome by its own internal contradictions.
Okay, that's the first negation.
But this is not absolute annihilation. The first negation sets the stage for a second negation.
The negation is negated.
Exactly. The negation is itself eventually negated. And this double movement results in a return to the original form or state, but crucially, at a higher, more evolved, or more complex level.
The text highlights a major critic of this specific idea, a philosopher named Herr Düring.
Oh, Düring, yes.
He looks at this negation of the negation concept and basically calls it academic fraud.
He wasn't a fan.
He accuses Marx and Engels of just ripping off Christian theology, saying this is just the secular version of the fall from grace, which would be the first negation, and the eventual redemption, the negation of the negation. He claimed it is nonsense to base scientific logic on a religious metaphor.
Düring represents the ultimate metaphysical pushback here. He is operating completely from the spreadsheet mentality.
How does Engels respond?
Well, to Düring, to negate something simply means to cross it out, to destroy it, to reduce it to absolute zero.
Right.
Engels uses a pretty brutal analogy to explain why Düring is wrong. He says, if you crush an insect under your boot, you have negated it.
Okay.
But you haven't set up any condition for a second negation that leads to a higher state. You just have a dead bug on your shoe.
So if I take a sledgehammer to my smartphone,
Yeah.
I've negated it, but I'm not going to get a quantum supercomputer out of the debris. It's just broken glass.
Engels agrees completely. He clarifies that dialectical negation is not random, violent destruction.
It's not just breaking things.
Right. It is a specific type of negation determined by the very nature of the thing itself. It is a process that preserves the essential substance while overcoming its current form.
And he has a natural example for this, right?
He does. To defend this, Engels points to nature, specifically the life cycle of a grain of barley.
The barley seed is the perfect organic metaphor for this. Walk us through it.
Okay, imagine a single grain of barley. It falls into suitable soil. Under the right conditions of moisture and heat, a specific internal process is triggered. The grain germinates.
So it sprouts.
Right. But dialectically speaking, as a distinct grain of barley, it ceases to exist. It is consumed by its own growth. It dies. It is negated.
That is negation number one. The seed form is destroyed.
But what takes its place? The plant that arises from it. The green stalk is the negation of the grain.
Right.
Now, that plant grows, it takes in sunlight, it flowers, it is fertilized, and finally, it produces new grains of barley in its head.
And then the plant dies.
Exactly. Once those new grains ripen, the stalk loses its vital force. It withers and dies. It is, in its turn, negated.
Negation number two. The plant is dead.
But observe the result of this double negation.
Yeah.
You don't have zero. You don't just have dead compost. You have a return to the original starting point, the grain of barley, but you have arrived there at a vastly expanded level.
Because there's more of them.
You don't have one grain anymore. You have 20 or 30 new grains. And if we consider human cultivation over generations, those new grains might be genetically hardier or more productive.
The cycle of double negation resulted in multiplication and evolution.
It's a spiral staircase, not a flat circle. You come back around to the same position, but you are a floor higher.
Floor higher. That's a great way to put it. Now, the text also applies this to mathematics, which was a huge aha moment for me.
It's unexpected, isn't it?
Totally. We tend to think of math as the most rigid, static spreadsheet discipline in the whole world. But Engels shows how the negation of the negation is baked right into basic algebra.
The algebraic example proves that this logic governs abstract thought just as much as botany.
Take a positive number. Let's just call it A. Now, negate it. It becomes A. That is the first negation.
Right.
Now, apply the negation of the negation. Multiply that negated number by itself. A times A.
A negative multiplied by a negative forces a positive result.
You get a squared. You have returned to the original positive state of a ter, but you have arrived there at a higher power.
Literally a higher power.
Exactly. It's not just the error anymore. The double negation permanently elevated it to a squared. The math itself demands the dialectical process to reach the higher power.
Engels doesn't stop at algebra either. He takes on differential and integral calculus, which is arguably the most powerful mathematical tool ever invented for understanding motion and curves.
I was really hoping you would translate the calculus section for us because, I'll be honest, trying to read 19th century explanations of calculus made my eyes glaze over completely.
It's dense material.
How on earth does calculus rely on the negation of the negation?
It is actually the most poetic application of the law, I think. Let's say you have a complex curved shape, and you need to find the exact area underneath that curve.
Okay, a curve on a graph.
Right. Using standard, static, geometry, metaphysical math, you just can't do it.
Why not?
You can draw little rectangles under the curve to estimate the area, but because the curve is constantly changing, the straight tops of the rectangles will never fit perfectly.
They'll poke out or leave gaps.
There will always be jagged gaps. Standard math just hits a wall.
Because standard math wants the curve to sit still, and the curve refuses.
Precisely. So calculus introduces a dialectical trick.
A trick.
In differential calculus, you take the width of those rectangles, which we can call x, and you shrink them. You shrink them so much that they become infinitely small.
How small?
You reduce them to what are called differentials, denoted as dx.
So you shrink the width to 0.
You bring them to the absolute vanishing point. You are essentially making the physical dimension of the rectangle disappear.
Okay.
You are negating the finite quantity of x. It becomes a ghost of a number. That is the first negation. You have conceptually destroyed the normal numbers to follow the infinite slope of the curve.
But wait, you can't build a bridge or calculate a planetary orbit using ghost numbers. You have to get back to reality.
Exactly. You don't stop at the destruction. You perform operations with these vanished quantities, and then you apply the second step, integration.
Integration.
Integration is the mathematical equivalent of the negation of the negation. It sums up all those infinitely small negated slivers and brings them back into real finite quantities.
It resurrects them.
Yes. But by passing through that process of double negation, by destroying the static number and resurrecting it, you achieve something impossible.
What's that?
You find the exact perfect area under that constantly changing curve. You solve a dynamic problem that ordinary rigid geometry simply cannot touch.
That is legitimately staggering.
Isn't it?
To find the truth of the moving curve, the math literally has to destroy its own static variables and then resurrect them. It actively relies on the negation.
It's pure dialectics in mathematical form.
So, having laid out these 3 intricate laws, quantity and equality, the interpenetration of opposites, and the negation of the negation angles, makes a phenomenally arrogant or perhaps just confident claim.
Very confident.
He states that these are not just clever philosophical thought experiments invented in a library. He declares they are the objective operating laws of the universe.
And we really have to place that confidence in its historical context.
The 19th century.
Marx and Engels were writing in the mid to late 19th century. This was not a quiet period in history.
No, it was exploding.
It was a time of absolutely explosive, unprecedented scientific and industrial revolution. The world was literally transforming before their eyes.
They weren't just debating theology in an armchair. They were watching steam engines tear up the countryside and scientists rewrite the rulebook of biology in real time.
And they believed that the scientific breakthroughs happening in laboratories all over Europe were completely shattering the old metaphysical view of a static universe.
It proved their point.
They felt the science itself was validating materialist dialectics, even if the scientists performing the experiments didn't necessarily realize it yet.
The sources specifically dedicate a lot of ink to 3 great scientific discoveries from this era that they saw as absolute, irrefutable proof of their engine.
Let's go through them.
The first is cell theory.
Right. Before the 1830s, biology was largely a massive cataloging effort.
Just listing animals.
It was a deeply metaphysical endeavor. Scientists looked at plants and animals as entirely separate, static creations constructed from completely different materials.
But then what happened?
Then Matthias Schleiden and Theodor Schwann proved that all complex organic life, from an oak tree to a horse to a human being, develops from a single, simple, universal mechanism, the multiplying cell.
Which perfectly proves the first law.
Yeah.
A human being is the result of the quantitative multiplication and dialectical differentiation of these microscopic units.
We are just built from quantity turning into quality.
We aren't carved out of a block of clay. We are a temporary balanced colony of billions of cells that are constantly negating themselves, dying off, and being replaced.
It proved a single dynamic thread connects all living matter.
What's the second one?
The second massive breakthrough they point to is the transformation of energy. This was championed by scientists like Robert Mayer and James Joule.
This is essentially the death of the isolated force, right?
Precisely. Before this, scientists thought heat, light, electricity, and mechanical force were all distinct, separate fluids or essences.
Spreadsheets again.
Right, isolated boxes. But the transformation of energy proved that energy or motion is never lost or destroyed. It merely transforms its quality.
Give me an example of that.
Well, mechanical motion, like rubbing two sticks together, doesn't just disappear into the ether when you stop. The friction transforms its quality into heat.
And heat can transform it to electricity.
And electricity into chemical decomposition.
So the universe is a closed loop of matter in motion. One form of energy negates itself only to become a qualitatively different form of energy.
There are no isolated boxes on the spreadsheet anymore.
But the third discovery is the one Engels says dealt the heaviest blow to the old metaphysical way of thinking.
Oh, absolutely.
And that was Charles Darwin's theory of evolution.
Darwin was the game changer.
I really want to linger on this.
Yeah.
Because it is hard for a modern listener to fully grasp the metaphysical shock Darwin delivered to the 19th century brain.
It shattered their worldview.
Before Darwin, the dominant view, even among many scientists, was essentially creationism. God created the finch, and the finch has looked exactly like that since the dawn of time, and it will look exactly like that until the end of the world.
Species were viewed as if they were stamped out of a factory mold.
It was the ultimate frozen movie frame. But Darwin completely shattered that static frame. He proved that all organic beings, plants, animals, and humanity itself are not fixed creations, but the fluid product of millions of years of historical evolution.
And what drives that evolutionary engine according to the texts?
It is pure dialectics.
Yes, it's the tension between heredity and adaptation.
Heredity is the conservative force, trying to replicate the organism exactly as it was. Adaptation is the active force, responding to environmental pressures, forcing mutations.
Opposites interpenetrating.
The interpenetration of opposites, locked in a struggle, forcing quantitative changes over millennia, until, boom, a qualitative leap occurs and a new species emerges.
Engels points out a really fascinating irony here, though.
Yes, that.
He argues that the scientists of his day were doing brilliant, world-changing work, gathering the actual facts. They were proving evolution, energy transformation, and cellular biology in the lab.
They were doing the work.
But because the academic establishment was still deeply conditioned by the old, rigid, metaphysical way of thinking, the scientists were often hopelessly confused by their own discoveries.
So they had the dialectical data, but a spreadsheet brain.
That's exactly it. They couldn't theoretically synthesize the fluid, contradictory dynamics they were physically observing in their own labs.
Wow.
Engels argued that dialectics was the only cognitive tool sophisticated enough to actually understand the new science. He famously stated that he didn't want to force the laws of dialectics onto nature. He wanted to extract them from nature.
Okay, this brings us to the ultimate pivot point of this entire deep dive.
The big shift.
We have applied this engine to boiling water, segmented worms, chemical bonds, and the formation of planets. The logic holds up.
It works in nature.
But what about us? If the universe operates on these laws of contradiction and qualitative leaps, how does this framework analyze human society?
And this is where we transition from the natural sciences to the core of Marxist theory, historical materialism.
Historical materialism.
This is the application of the exact same dialectical lens to human history and civilization.
So we take the engine that explains how a barley seed evolves, and we just aim it directly at economics and politics.
Yes. Marx and Engels argued that just as nature is not a static, unchanging creation, neither is human civilization.
Right.
And just as they flipped Hegel's idealism in philosophy, bringing the focus from abstract ideas down to physical matter, they flipped how we view history.
Because the traditional view of history is that it's driven by, abstract ideas or the spirit of the age or just the brilliant tactical decisions of great kings and generals.
Historical materialism says that is all just surface noise.
Surface noise? So what's actually driving it?
History is actually driven by the material conditions of production. It is driven by the physical, economic interactions of human beings trying to feed themselves, clothe themselves, and build shelter.
There is a quote in the text from Marx's book, The Poverty of Philosophy, that is arguably the most famous and punchy summary of this concept.
The mill quote.
Yes, Marx writes, "The hand mill gives you society with the feudal lord, the steam mill, society with the industrial capitalist."
Let's break that down because it perfectly captures how the material tools force the social structure to change.
So the mill represents the productive forces of an era, right? Like the
Yeah.
technology, the infrastructure, the tools.
Exactly. Now, the hand mill is a rudimentary piece of technology.
Very basic.
It requires a specific decentralized social structure to operate it, and to distribute the relatively small amount of food it produces.
Okay.
That specific material reality, that specific mode of production naturally generates and actually requires a feudal society.
So the tool dictates the society.
Yes. You have lords who own the land and serfs who are tied to the land, working it with hand tools. The social structure fits the technology perfectly.
But then, a quantitative accumulation of human knowledge and engineering leads to a massive qualitative leap. The invention of the steam engine.
The game changes completely.
Suddenly, you have the steam mill and the mechanized factory.
Mm-hmm.
And here is where the dialectical contradiction kicks in, right?
And does.
Because you cannot run a centralized, mass-producing, steam-driven factory system using decentralized medieval serfs who are legally tied to a lord's estate.
The new technology demands a new way of organizing human labor. The new productive forces, the steam mill, come into direct, unavoidable dialectical contradiction with the old social relations feudalism.
The tension builds between the new economic reality and the old political laws.
And eventually that tension reaches a nodal point and the old system is negated.
Often a violent qualitative leap.
Like the French Revolution, for example.
Right.
A new society emerges that is tailored to fit the new technology. Industrial capitalism, characterized by urban factory owners and wage laborers. The material tools forced a qualitative change in the political structure.
To bring this into the 21st century, you could argue that you cannot run a global, digitized, AI-driven information economy using the regulatory frameworks and labor models of a 1950s factory town.
That's a perfect modern parallel.
The technology creates friction with the old laws, and eventually something has to snap.
That is the exact analytical method applied to modern conditions. Now, the texts also break this down at the microeconomic level to show the dialectic in action within a single product.
Within a product.
Yes, they trace the life cycle of a commodity, like cotton.
Oh, right. It's an economic negation of the negation.
Exactly. You start with raw cotton pulled from the field.
Okay.
Human labor acts upon it, feeding it into a spinning machine to create yarn.
So it's not cotton anymore.
The physical substance of the cotton is preserved, but its original form has perished to make way for a higher form. The raw cotton has been negated into yarn.
But you can't wear yarn.
So a second negation occurs. The yarn is woven into a finished dress.
Negation of the negation.
The substance remains, but the form has been transcended again. The cotton has achieved a higher use value. It is now ready for direct human consumption.
And Marx argued that human societies evolve through historical stages in a very similar necessary sequence, driven by the constant improvement of their productive forces.
Which brings us to the ultimate revolutionary implication of this entire framework.
We talked earlier about Hegel, and Hegel had a famous maxim, all that is real is rational.
Right. Hegel used that phrase to essentially justify the political status quo.
Because he worked for the state, didn't he?
He was employed by the Prussian state, and he was effectively saying, the Prussian monarchy exists, therefore it must be a rational manifestation of absolute idea, and therefore it is justified.
That is a deeply conservative conclusion.
But Marx and Engels took Hegel's own dialectical method, the engine he built, and showed how it completely destroys that conservative conclusion.
Because if the first law is true, and everything is in constant motion.
Right.
And if the second law is true, and every system contains internal contradictions.
Yes.
And if the third law is true, and those contradictions eventually force a negation, then that famous phrase gets completely inverted.
As the text summarizes, the dialectic dictates that all that exists deserves to perish. It is a profound and unsparing philosophical shift.
Deserves to perish. That's heavy.
Dialectical philosophy dissolves all conceptions of final absolute truth and absolute permanent states of humanity. It reveals the transitory character of everything.
So nothing can endure against it except the uninterrupted process of becoming and passing away.
Which means no political system, no economic system, no empire, and no technology is permanent.
They're all just temporary stages in a moving process.
And they are all actively generating the seeds of their own destruction.
And this is where we circle back to our impartiality disclaimer from the start of the deep dive.
Yes, very important.
Because Marx and Engels use this specific framework of historical materialism to analyze the capitalism of the 19th century.
They did. They mapped out what they saw as its fatal internal contradiction. The tension between the highly socialized collective nature of mass industrial production and the private individual ownership of the profits.
And they predicted that this specific contradiction would accumulate quantitative pressure until it triggered a qualitative leap.
Which they believed would be the dialectical collapse of capitalism and the rise of a classless society.
That was the destination they drove the machine toward.
Right.
But the value of our deep dive today isn't about predicting the future of global economics.
No, it's about understanding the framework itself.
It is about recognizing that historical materialism is simply the application of the three laws of dialectics: quantity into quality, opposites, and negation to human development.
We have moved from looking at the world as a frozen movie frame to watching the motion picture in real time.
That is the perfect summary. We have taken a dense, incredibly intimidating 19th century philosophical framework and revealed it as a vibrant lens for looking at reality.
It really is a powerful lens.
Dialectics teaches us that nothing in the universe is isolated. Everything is connected. Everything is in a constant state of motion.
And most importantly, tension and contradiction are not mistakes in the system. They are the required engine of all growth and change.
We saw how quantitative pressure forces qualitative leaps, teaching us that more eventually becomes different, whether you're boiling water or organizing an army.
We saw how polar opposites mutually define each other, locking together in a cosmic tug-of-war that drives the motion of planets and biology.
We saw how math itself relies on the negation of the negation, destroying static numbers to find the fluid truth of a curve, just as a barley seed dies to multiply itself.
And finally, we saw how the material tools we use to survive shape the political structures we live within, forcing society to evolve as technology evolves.
So why does this matter for you listening right now?
Well, to be truly well-informed is not just about memorizing a massive list of isolated facts.
Right.
It is not about categorizing the world into a rigid spreadsheet. True understanding comes from grasping the hidden relationships, the underlying tensions, and the continuous motions between those facts.
When you adopt a dialectical lens, you stop seeing permanent structures and you start seeing temporary stages in an ongoing process.
It fundamentally changes how you view change itself. Change isn't an anomaly that disrupts the system. Change is the system.
Which leaves us with a final thought for you to ponder on your own. Dialectical materialism argues that absolutely nothing is static, and that all systems secretly contain the contradictions that will eventually tear them down and build something new. I want you to look around your life today. Look at a belief you hold very strongly, or look at a piece of technology you rely on every single day, or look at an institution you live within that feels completely permanent and unchangeable right now.
What is the hidden contradiction inside it right now? What is the unseen tension that is already acting as the seed of its future negation? Because if the laws of dialectics hold true, the frame is already moving. You just have to know how to watch the movie.